Okay, question 1. And before anybody says anything, Deborah, yes, I know you need it. Okay.
Thanks.
No problem, I got you. The mass
Can we just do
blah.
all of them?
Probably.
Yeah, for real.
I may not necessarily do 100% of them, but a couple things I know for sure I'll probably need to show you on like the calculator. I'll go over a couple of those things. Um, you missed number 1?
Yeah.
I missed number 1.
I really tried on it too. That's part of the problem. Like I
Yeah.
did it and then I got it wrong and I was like, well, I'm just
Okay,
kidding.
hold on. 2 questions I got for you people. First one being, I'm going to hope you know this. What does instantaneous rate of change mean?
The
Derivative.
Okay, question number 2, because I'm pretty sure I know the answer to this. Did you do it by hand?
I did.
Yes.
Why?
Because I didn't know how to do it any other way.
The calculator
No, I
does it
just
for
didn't do
you!
it.
I still do not know how to do it in the calculator.
Wait, I
Well,
got green? What the frick? How the hell did that happen?
there we go. Alright, so you should be on the stream. I'm pulling up the calculator. We'll go over. Let me clear out.
Okay.
Clear all this. Clear.
Is there a way that I can look at both the and AP Classroom on my computer at the same time?
Yeah, I have 2 different windows.
Well, how do I do that?
2 tabs.
Yeah, they're in 2 tabs.
Open one tab.
Okay, click.
But what?
Hold on, stop. Click on one tab, like on the top where it says its name, and then
Yep.
drag.
Drag to where?
Anywhere else.
But
It'll open a second window.
oh, okay.
And then really easily what you can do is you can just hit Alt Tab and it'll go back and forth between the 2. As long as those are your 2 most open recent windows. And you can make one small and like...
Wait, where's the tab button? Oh, there it is.
Are you on a...
Wow.
Oh.
Okay, cool.
Okay. Or you could be, you know, cool and get 2 monitors.
Yeah, well, I don't have that kind of money, so...
I won't do anything without 2 monitors. Okay, so everybody sees the calculator on the screen? Yes? Wait,
Yes.
Okay, so we are trying to, I forget, hold on, let me pull up the question. So you want to take a derivative. Well, we have this lovely button for integrals, which is math. Button for integrals, math.
9.
What did we learn before integrals?
8 derivatives?
What did we learn before integrals? 8.
Sorry.
I mean, she's not wrong, it's a derivative.
So math 8 then would make sense. That is our numerical derivative. I'm going to go ahead and enter this into y equals because this is where y equals, which is where you should have already had it anyway. So 2
Oh, look, it's already there. How
plus
convenient.
arctan 5. You second.
Oh, wait.
I don't like not having these physical buttons. And then x over 2.
And you plug in 2 or 6 for x.
No, we don't plug anything in. So we just need that in our y1. We go back, and now we're going to put things into our derivative. Alpha y equals.
Oh, I meant there because
y1.
I already have.
Okay, then yes, we are entering 6.
Okay, well.
Hey, look at that. The calculator did all the work for me. I did nothing.
Wait,
why is x equals 6?
Because it says
6.
at the moment.
Okay.
The answer is 1.2.
Yeah.
Oh, because we're all dumb and I didn't read the question and I just followed by what you said.
But we didn't say anything.
You said x
True.
equals 6, Deborah.
It does.
It does not. What is x in this problem?
T.
Okay, what is t then?
Time.
This says 6 grams.
Okay.
Yeah, that threw me off.
So you're solving for...
So what does the 6 equal? What does that 6 represent?
P of t.
P of t. So this requires a little bit more work. So I've got my function. This is my y function. I need it to be equal to 6. We walked through this last week on one of the problems. I'm going to do it again. You have one of 2 options. If I want this function to equal 6, I can come down here to my second function, have 6. I'm going to refresh you real fast. Oops, I need to change my window. See, so I'm starting at 0. I want 10 days should be more than enough. And I want it to equal 6, so my y min is going to be 5. And y max. Okay, a couple things to point out about my window here. I'm starting at 0, so I changed my x min to 0. I'm assuming this is going to happen before 10 days. So that's just a guess. I might have to change that. My y's, though, notice how I want my function to be equal to 6. So I only need just on the opposite sides of 6. So I did 5 and 7. And then when I go to look at my graph over here now, I now see it happens right there. So I can calculate the intersection of my points. It looks to be about 2 something. So we go to calculate. We're going to calculate the intersection. So number 5 down here. Piece of advice when you're calculating intersections, you want your cursor to be close to the points of intersection. So I move my cursor until I'm right on it. I hit enter. It'll move the other one right there. Hit enter. And then never guess. So 2.059. That is your x value. Does everybody follow how I just did that?
Yes.
Yeah.
Anybody have any questions on what I just did and need me to do it again or explain anything I did? Okay. So now that we have that, you have a couple of options. Do you really want to remember this number or write this number down and enter it a whole bunch?
Maybe.
No.
No.
So we
Okay.
have an option. If you get out of your
Can't you
graph,
just save it?
that's what I'm about to show you, yes. Go back to your normal calculator screen, hit this little stow button in the bottom left. Oh, why did it not save my answer? Go back and calculate my intersection again. 5.
Wait, it's stowing my answer.
It should be. They should
Okay.
stow this. I don't know why mine didn't for some reason.
Wait, mine's stowing like the 0.25. Hang on.
So after you gotta do it immediately after you calculate that before you do anything else. Otherwise the calculator loses.
Oh, I thought you
its
said go
memory.
back to the math screen, so I
Yeah, you hit
did.
second quit to do that.
Well, but then it's stowing not the intersection.
So it should. So if you hit calculate, do your intersection. So, and then
Okay.
after it says guess, hit enter. Don't do anything after you've done that except for hit second quit. If you do anything in
Second
between
quit.
that, then it won't stow properly. And then you hit stow, it should say answer stow. And then you can, I just use A because it's right by it. And it'll show that number 2.527, blah, 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 blah. Now, alternatively, you can just write it down if you don't want to do it that way. If you're going to use that number multiple times, it's really useful. If not, you can just type it out. Not a big deal. And now we can do our derivative. Dx, oops. Y1 at my A value. And we get 1.23. So if we round that properly, 1.214.
Oh, okay, that's neat.
Again, if you're only using it once, you don't need to necessarily stow. You can just write the number down and then do it. It's up to you. If you're going to use it multiple times, it's useful to stow that answer. Even though you're on a computer, we can still hear your phone, Deborah.
Well, I'm still using my phone for Discord.
Oh, okay. All right, so any questions on number 1? That was definitely a setup to trick you, I'm not going to lie, if you're not careful. Okay, number 2. I'm going to assume most of you forgot how to do your linear approximations.
Oh, I got it.
Yes,
Yeah, I
please
forgot.
go over it. Please go over it.
So
I looked at the formula and still did it wrong.
most of you are probably going to remember something along this and think it's super complicated because you don't ever make the connection. So that is your linearization formula. That's on Twitch. It'll be on there in a second. You look at that and go, how the hell am I supposed to remember that? That's all whatever. Well, you don't. It is
Put it in
just
your calculator.
slope, intercept, or point slope, sorry. So that is nothing more than a point slope form that is made to look fancy. Okay. And now to address Thomas's question, because I knew it would be at least at some point arising today. In case you do not follow Trevor Packer, who is one of the people high up on College Board, which you probably should, especially at this time. He tweets out a lot of useful information. In
I
case
just
you,
don't use Twitter.
well, you should
What
still
does
at
it
least
say?
like follow what he does and says. In case you don't know, your AP Calc test will be open note. Open
For
book.
reals?
For reals. Guess why that is?
Why?
Because it's going to be really hard.
No, because you're taking it at home and we're not done. We know you're going to cheat.
Sweet.
Yeah,
So-
no, they do.
So,
So we think
so if we make it not cheating, then you can do it because, well, what's the majority of people going to do if it's taken at home?
Yeah, I was gonna use my
Yeah.
notes anyway.
I didn't know how they were going to solidify that, so, you know.
Okay, whoever's in their car needs to mute Discord.
Jesus.
Is it Annabelle again?
Wait, what?
Is Annabelle driving again?
No, there's an airplane above my house.
You,
Jesus.
It
There's
won't go
this-
away.
okay, Annabelle,
Yes.
bottom left, user settings. It looks like a cogwheel.
Okay, there's so many tabs that I'm just switching by. I didn't know that airplane was gonna drive over my house for that long.
You're fine.
My house too. That's so funny.
But user settings, you can go from voice activation
Oh my God,
to
it's
push
coming
to
back.
talk.
Is
So,
it just circling over Annabelle's house? She's
Probably.
not going to be there for much longer.
so
It's
you
gonna
don't have
take
to
her out.
mute yourself if you don't want to. Push to talk is a very useful thing. So bottom left user settings, especially if you're on a computer, push to talk. So you'll only talk if you push that button. That's also a very helpful setting.
Okay, he's
But you
gone.
have to be in the tab to be able to push the
Can you hear
button.
me?
No, you could
Yes.
just download
Yes.
the app instead of using the window.
An
Okay,
app.
thanks. I've been
That's
trying to see if
a
my
word.
push to talk works for like a whole week.
Yes. Yeah, if
Oh
you're
my God,
open,
there's so many airplanes.
Also, what's a good key for this? Because if you pick a letter, it starts typing.
I use control for mine.
Okay, I have the end button right now and that's going okay.
Yeah, either control, alt, shift. Those are good ones.
Alright, well, I did shift and then it was something about sticky keys and I was like,
Yeah, you just disable sticky keys. It's for old people, basically.
oh, okay, cool.
I still can't see the board on Twitch.
Okay.
That's
How
because
do
I have
do
the
this
calculator
push to
pulled
talk
up.
thing?
Oh,
wait.
I thought you said it
And
was
nobody
going to
told
show
me.
up in a second.
I said nobody told me. I forgot I had the
Oh.
calculator pulled up.
Look for voice and video settings.
Yeah, and then it's voice activated and push to talk, PTT.
Haha, there is the formula.
Yes,
It's
sorry.
under input mode.
Okay, so sorry, I forgot I had the calculator up. So there is the fancy looking formula for linearization, and then right below it is point slope, but I moved the y1 over. Notice they're exactly the same because what is f prime of a?
Slope.
Slope. It's your derivative evaluated at a. It's a slope. F of a is a y value, a is your x coordinate, etc., etc. So basically, it's just a fancy modified version of that. They give you all of the information, with the exception of the actual derivative value. So I'm going to write everything out, and then we'll just solve it. So 1.2, 7.5. And then what is this? 2 plus 9e. And my slope is 2 plus 9e. What's the exponent on e, somebody?
Is this working?
Yes.
0.4 sine t.
Yes, it's working, Annabelle. And our t is 1.2. Also, whoever's crinkling something, you should learn push to talk as well. So there is your linearization formula. Now, obviously, I would suggest, since this is calculator active, figuring out what 2 plus 9e to the 0.4 sine of 1.2 is. I didn't have my calculator on me at the time, so I don't know what that is, but do
Wait.
that. What?
That's so hard.
Okay, that's what
I
I
know you-
did. I just goofed it up somehow.
Okay. So then they want us to find the at what value of t does a of t equal 15. So where am I going to put that 15 into my linearization formula?
The x? No, the y.
So that is my y value. So you just plug 15 in for y and then solve using your calculator. So you get 15.
Wait, why would it be sine of 1.2?
Because that's your x
Oh,
value.
wait. But you're trying to find the x value that it is when it equals 15.
Right, but you use the given information to write your linearization, which is what I did for the first line. Then you solve for something using that linearization.
Okay.
Equals.
Okay, I went to do that, and I guess I don't know. I don't think I finished actually calculating it.
A little bit of advice before you multiply out whatever this nasty ugly decimal is, just divide by it instead. 90.4 on both sides. So whatever that decimal is, I just don't feel like figuring it out right now. And then after that, you would add 1.2 to both sides. So I'm not going to do that part. Okay. Make sense, hopefully? Okay. Next question. Okay, so A of t, what does A of t measure?
Yeah, I don't know.
On number
Oh my
3.
gosh, I got one right.
The area covered by oil.
Okay, so that, how could we say that in a general thing? A of t measures in.
Like a value? Like a number?
Correct. That's a way of putting it. I would say it measures an amount, though, because, I mean, technically everything's a number, but it measures an amount, how much there is of something. Well, if I want a rate of change, because it wants the rate at which the area is covered, if I have an amount function, how do I get a rate function?
Take the derivative.
Take the derivative. So clearly the only answer with the derivative in it is D.
That do make sense though.
Yeah. So the more important part here is to analyze what exactly the other ones mean. So what does A mean? A of 10, what would that represent somebody?
Just plugging 10 into the function.
Well, clearly, but what does that represent?
That wouldn't be a rate. That would be like the value.
The square centimeters.
Okay, none of you have hit it correctly on the head yet. You're getting close.
Oh, the
The
area?
amount of oil at that time.
Okay, generally
It's
speaking,
the
yes.
area of oil covered.
That would be an incorrect statement.
Or, well,
You have to
I
be
know
The
careful.
amount of oil?
So you're missing out on the important point that Thomas said. At that time, so at time t equals 10. This is where on your explanation points on your free response, which as we've figured out, the whole test is now free response, you will lose points. It is the area covered at time equals 10. That's a very important note to put. What about A11 minus A9?
That's just like FTC.
No, that is not FTC.
I don't know what it meant. It just looked weird and I didn't like it, so I didn't choose that one.
What would A11 represent?
The wrong answer.
Clearly, but what would A11 represent? We just
The
went over
area
this.
covered at time 11.
Yeah, but what would A of 9 represent?
The same
The
thing at
area.
9.
Yeah.
What would A11 minus A of 9 represent then?
Not 10. A of
Oh,
10.
A at t equals 1, right?
Huh?
I'm sorry, no. That's not it. No, don't listen to
The
me.
difference
Oh,
between the
like a
two.
secant slope.
There you go, Miguel.
Yeah.
And Bridget
That
started
was
to hint.
Bridget.
That was Bridget.
Miguel had the correct answer. Bridget was hinting close to something that could be used, but not correct.
I didn't even hear Miguel.
He said the difference between them. Like, that's exactly what it is. It is literally just the change, how much area is covered from 9 to 11. So if I take the amount that's covered at 11, subtract the amount that's covered at 9, that would be the change in the area. So that would be how much area is added between 9 and 11. And then C has no actual contextual meaning. I couldn't figure out anything of what that would be, so I don't know.
I think they're trying to multiply A times 10 and then just divide it by 10.
Well, what I think they were doing was using slope from like a of 0, but a of 0 would not necessarily be 0, so it's just kind of all kinds of messed
Oh,
up.
I see.
So it's just all kinds of bad. All
Very
right,
wrong.
number 4. Questions?
Hmm.
Okay,
Yeah, I
never
got
got
this one
this,
wrong.
surprisingly.
that's fine.
I even tried on this one, so.
So here the wording is the important part at the very end of the statement. What does it mean to be instantaneous rate of change?
The tangent slope.
Okay, give me something
The-
else.
Derivative?
0.
Okay, not the derivative. You gotta be careful.
Why?
Definitely not 0 either.
Like the change at that point.
So say it again, Bridget.
The change at that point.
Sort of. You're getting close, but those aren't words that we would necessarily use often.
The rate of change at a specific time.
That's why it's called instantaneous rate of change. Yes.
Well, you're asking.
There are 4 phrases that we use that are the same thing as instantaneous rate of change. Slope of the tangent line's already been given, so there are 2 more.
Derivative.
Derivative is not correct.
Oh, fuck.
Instantaneous
Why not?
slope.
It was right a minute ago.
No, it was not right a minute ago. Instantaneous rate of change, we said, means we need to take the derivative. Does not mean it is the derivative. The derivative is a function in most cases. Instantaneous rate of change could be slope of the tangent line, which is fine. The derivative at a point, that's the part that's important, that adding on at the very end is the derivative at that point. Because if you look at the curve, is the derivative the same everywhere?
No.
No. And we're talking about instantaneous, which means at one instant. Go ahead, Bridget.
So do you know what like unit linear approximation was?
Not off the top of my head.
Gonna take a wild guess and say unit 4.
Well, she's talking about in our book. I want to say it's probably 5.
Oh, is it different in our book?
Yeah.
Oh,
Okay,
weird.
because like I didn't remember what that was, and it was really late, so I didn't.
Yeah, it's probably
try
5. So again, instantaneous rate of change, and if you don't know these, you should be writing things like this down. Instantaneous rate of change is same thing as slope of the tangent line, the slope of a curve at a point, or the derivative at a point. What is average rate of change? We don't talk about this one as often in this form, but we do have at least one other
Secant
thing.
slope.
So the one we usually don't use is we don't say secant slope, we just say slope, but yes, that is correct. It is the secant
Slope
slope.
between 2 points.
Yeah, that's usually how we would say it, which is the secant slope. It's just not a word we use all the time. So that's where this one could have thrown you off. So basically they're asking you where is the slope of the tangent line, the same thing as the slope of the secant line. If they'd asked you that, I'm going to hope that most of you would have gotten that correct.
Probably not.
I said hope. But, so basically if you look, if you draw a whole bunch of tangent lines, where would the tangent line be parallel to the secant? And you should hopefully notice that there are 3 of those.
Yeah.
Why is there 3?
Yeah.
Just take
Because, like, I knew all the thing about the secant line.
watch. Take like a pencil.
Would it be like
Hold on. Just take a pencil and move it along the curve. And anytime it's then parallel to your secant, stop and count it. 1, 2, 3.
Oh.
Wait,
it
what?
like all the like peaks of the curves?
It won't necessarily be at the peaks. We can't say that for sure, but it'll be somewhere around them, yes.
Wait, hold on, I'm confused.
So again, take your pencil if you're confused, and use it to represent a tangent line on the curve.
Oh.
How many times is your pencil parallel to the line that's drawn there?
3.
Okay.
That's basically what the question is asking. How many times is the tangent line parallel to the secant line? And you should notice that it is 3 times. Okay. Any other questions on that one? That was a pretty straightforward one. Okay, number 5.
Nah.
Hopefully should have been easy.
I got this one.
Okay, so just to make sure, in case anybody doesn't want to speak up, it changes direction when the velocity value changes from positive to negative or vice versa. So at 1, 2, and 3. 4 does not count. 4, it comes to a stop, but then keeps going in the same direction. So 4 does not count. So your answer should have been 1, 2, 3. Number 6. Oh, this one's a pain.
Yes, please go over it.
Notice also this is non-calculator on this question.
I got it though. I'm so happy.
Oh, Jesus. And what's your question, Bridget?
Shut up, Thomas.
Like, they say it's gonna be open notes, but like, it was just gonna be that either way.
That's why they're letting you use your notes
But now
without
we
it being
can't get in
cheating.
trouble for it.
Who's
Yeah.
gonna fucking tell on us?
Because there are people who would have taken it non-open note because that's what's supposed to be done. So they didn't want that to happen. Yes, that sucks for being an honest person.
Well, we're not honest at Bay High.
AP is a scam.
AP is not a scam, and I would have thrown stuff at all of you and reported you to College Board if I found out you were cheating.
That's why you wouldn't have found out.
That's true.
I would have found out.
No, he wouldn't have found out. He would have just known. He would have been
You're
like,
never.
yeah,
You're
I
not
know
gonna
my
see us for the
students.
rest of the year. How would you know?
All I gotta do is tell your mom to watch you take the test, Deborah.
I'll take it at my dad's house.
I'll tell your dad then.
Oof.
You act like you can't contact him. I'll have
You act like
Michaela.
my parents
at
don't
work.
have work.
I will get Michaela to watch you. She'll
She
narc
has her
on
own
you.
classes to deal with.
I'll pay her $20. She'll
That's
narc on you in a
what
heartbeat.
we'll do.
Okay.
Right.
So for number 6, at this point, this one's a little bit harder because I'm assuming what most of you did that got this wrong, you just plugged in 0, plugged in 5, subtracted the 2 values. You also probably used a calculator.
I
I
did.
guessed.
Tell me I'm wrong on any of those accounts.
You are.
I didn't just plug in 0 and 5.
I
I
didn't
took
use
the
a
derivative
calculator.
and factored it.
I
and it was
completely
like
guessed
two
on the
different
question,
numbers.
so
Go away, go away. Why is this some random person following me on Twitch?
He wants to educate himself on calculus.
People are weird.
There's 425 viewers on this Twitch.
Nah, that's total views. I mean, how many? Like, if every time you log in, it counts as a view. So
Oh.
that's not
Still, that
active.
seems like a lot.
Well, if I've had class for 3 days and there's 20 of you here, that's 60 of them. So plus all the
I
free
guess.
calc. All right. So this part, the problem with this question is since we're doing distance traveled, if we had a graphing calculator or calculator active, no problem on this question whatsoever. But because we are doing it without a calculator, we have to figure out where it's changing direction. Couldn't think of the word. Because if it's changing direction and I just do an integral, that's displacement, not distance traveled. If we had a graphing calculator, remember, we could just do an integral of the absolute value of the velocity function. But we don't
an
have
integral.
that. Yes.
Wait, which one are we on?
6.
There you go. So we have to remember that because we know more calculus than what they're teaching us, the integral of...
Are we on 7?
6?
6.
So we have to remember that we know this already. Again, we know a little more than what they expect us to know, so we can apply those techniques. It doesn't matter how we do the problem. So we know that to be true. However, we can't do that because, one, we don't have a graphing calculator. So we've got to figure out doing it a slightly different way. So instead, what we have to look at is we have to analyze it and figure out where is it traveling in which direction. So in order to do that, we take a derivative. Someone read me the position function.
2t cubed plus 3t squared minus 36t plus 50.
Okay, so we need to evaluate and look at our velocity function. So we get 6t squared plus 6t minus 36. Set it equal to 0 to analyze its direction. So divide everything by 6, you get t squared plus 1 t minus 6 equals 0. So factor that into what, plus 3
Wait, what did you just do?
minus 2.
Oh, you said it equal to 0. Okay.
Yes. So we looked at our velocity function, set it equal to 0 to figure out when that function is, or when the particle or whatever it is going left, right, etc. Because that'll make a difference. So this tells me that it possibly changes direction at +2 and -3. Well, I don't care about the -3 because my time starts at 0. So I put 0 and 2 on my number line. Look and see where it's positive or negative, basically doing number line analysis. So in between here, it'll be positive and then negative. And I'm doing from 0 to what, 5? Okay. So the problem is I now have to break it up into 2. So since we know more calculus than what they're expecting us, you have one of 2 options. You can do the integral from 0 to 2, the absolute value of it, plus the absolute value of integral from 2 to 5. And that'll be your answer. That's one option. The other option is to use our position function, which is what they're expecting you to do, because they don't expect you to know how to do integrals yet. You can just plug it into the position function, which is the same thing you're going to get when you do the integral anyway. And then plug in your 0, 2, and 5 values and figure out that. So in other words, to show you what I mean, so if I plug in 0, it should be easy, 50. 2, I'm not doing that in my head. Anybody know what you get when you plug in 2 already? Somebody should have this done. Somebody? Anybody?
I don't think anyone does.
I got it wrong, so I couldn't tell you.
Wait,
I think
why
it's
is
18.
why is it 0 to 2 plus 2 to 5?
Because we're trying to find the distance traveled, and I'll show you in a second why.
Where'd
This
you
is-
get those numbers?
I can do it for you. I'll pull up the calculator.
Well, that's what I'm doing. I'm just putting it in the calculator right now. So 2, so that's 16 plus 12 minus 72 plus 50. And it's 6. Nice try, Thomas. And then do the same thing with 5. So we get 2 times 125, so 150. Sorry, 250, because I'm crazy. Plus 75. Minus 36. Alright, and then I get 195 for that. Okay, so now the question is, why are those numbers important? We're looking for the distance traveled from 0 to 5. If I plugged in 0 and I plugged in 5, and I just look at just the 2 beginning and ending values, that's going to tell me I want a distance of 145.
Wait, what?
If I look at the beginning and the ending value, it would tell me I want a distance of 145.
Okay.
Is that true?
Mm,
No.
No.
No, because what happens in between 0 and 2?
It changes
Mm.
direction.
Yeah.
Nope, in between 0 and 2, what's happening between 0 and 2?
It's
No.
positive.
It's going away from 50.
Well, it's always going away from 50. Be more specific, Thomas.
It's
Negative.
never mind.
So it's going to the
Left.
left.
Wait, why is it going to the left but it's positive?
Because where do I start at?
You start at 50.
Where do I end at?
6.
So which way do I have to be going?
Left.
Oh,
Left.
but it's positive.
Just does left tell you if you're positive or negative?
No.
No.
Left can be positive.
Wait, I'm confused.
Does going left or going right tell you where you're located?
No.
No. Going left or going right tells you your direction. So if you're going left, you can be both positive or negative. You could be 0 as well. However, I just know you're going left. So in between 0 and 2, how far does the object travel?
484.
44. So that means the integral from 0 to 2 would give me a value of 44. Now, if you do the actual integral, you're going to find out that it's going to be negative 44. Because remember, the regular integral will give you your displacement. So it says negative 44 because that means I went 44 whatever units to the left. But I want a distance, so I'm making it positive. Then when I do my integral from 2 to 5, then I'm going to get the distance between 195 and 6. So which is what, 189? Plus 189.
Oh, wait. Okay.
And I have my velocity backwards. Nobody caught that. It's negative, positive.
Mostly because I don't know what that means.
It tells you what direction is. Velocity tells you direction and how fast you're going.
I kept trying to ask why from 0 to 2 was positive, and then we were going. That's why I was so confused.
I was just testing
Because
you, duh. So then you add the 44 and the 189. And I'm assuming that's 233 because I don't feel like adding in my head. Any other questions on number 6? Okay, 7. Oh, definitely need to do this one.
Yes.
So as I'm erasing and writing stuff up here, how do we tell if something's speed is increasing or decreasing?
the number gets bigger.
Doesn't the acceleration and velocity have to be the same
For which one, Miguel?
for speed?
No.
Uh,
Wait, are we on number 7 now?
We are.
Yes.
Okay, I'm so angry that I thought because I don't know how.
It's okay. So how do we tell if something's speed is increasing?
If the
Okay,
acceleration
don't
is
you do
positive.
like a number line analysis of like position and velocity?
Velocity and acceleration have to be the same sign.
There you go. Bridget finally got it. So
Oh, what?
I will combine that with what Kayla said, except for we just need to modify the functions. So we are going to do a number line analysis with your velocity and your acceleration. Because in order to be increasing, your velocity and acceleration have to have the same sign. Okay. So somebody read me the function because I already forgot it walking over here.
T cubed
Okay, wait.
minus
Sorry, go
6t
ahead, Deborah.
squared plus 9t.
That's the velocity function, right?
Yeah, y of t.
Okay.
Actually,
Wow.
this is position is
position.
given.
Okay. So y of t, v of t. Okay, so we'll take both derivatives. So you get 3t squared.
So the speed could be increasing in like the negative direction, right?
Yeah, put your car in reverse, hit the gas pedal. What happens?
Okay. Like you're speeding up backwards?
Yep, you're getting faster, but you're going in the negative direction.
Okay, I just didn't think about that.
That's fine. So we get our velocity and our acceleration functions.
Wait, hold on. Okay, so you know it's increasing when.
They have the same sign. We'll talk about that in a second. So first thing is we
Well, I
get.
was writing it down.
Okay, I'm going to go over it all. I promise you. So you have your velocity and acceleration. You need to get where those are equal to 0. So you could solve those hopefully pretty easy. So this is going to be what, t minus 3 and t minus 1. So at 3 and 1. And this one happens at 2. So those are where those values are equal to 0. So basically setting your derivatives equal to 0. We then do our number line analysis with both v of t and a of t. So our numbers need to match up on all of them. So we have 0. Where do we stop? What time do we stop at?
4.
So we start at 0 and stop at 4. I need to put all of these numbers on both number lines. So it's pretty... Pretty easy because it's 1, 2, 3. Okay. And then we just need to figure out if that function is either positive or negative at that time. So I always start with my top function, in my case, the velocity function. So if I plug a number in between 0 and 1, is it positive? In between 1 and 2, is it positive or negative? 2 and 3, etc., etc. So it should be positive, negative, negative, positive. I did that right in my head? Yes. Then your acceleration should be even easier. Should be negative, negative, positive, positive. And all you're doing is just plugging in values. It works very easily to plug them into the factored form. So when I did that, I just looked at the factored form right here. A number in between 0 and 1, both of these are negative. 2 negatives makes a positive. In between 1 and 2, this one's positive, this one's negative, this one's positive, makes a negative, etc., etc., and just went down the line. So that's how I did those so quickly, in case you were wondering. That group chat has 20 messages in it. I'll read them later. Okay, so we are looking for speeding up. Speeding up happens when they have the same sign. So there and there. If I was looking for slowing down is where they have opposite signs.
Every time you go over this, it makes sense. It's just like, I can't do it.
I don't know what to tell you then. Make notes to yourself and study these things. This is what I would call a basic concept definition that you need to definitely be able to apply. Particle motion, I would have said what is 100% going to be on your test, but I don't know what they're doing since we can't do the integral part of it anymore. So I don't know how much of it will be where. We'll find out more on Friday. But that concept,
we can't do integrals?
The integral part of particle motion is not on the test.
Oh.
So I don't know what they're going to, because particle motion has 100% always been on a free response question forever. So it was always guaranteed to be there. Now what you did with it was a different story, but particle motion was almost always, like, I don't know if it tested it wasn't on the free response. So.
Okay, so from 1 to 2 and from 3 to 4, it's increasing.
Speed is increasing, yes, because both of them match. All right. But yeah, that's definitely a concept that appears over and over and over and over. Number 8, I hope I don't need to go over. Go ahead, Deborah. Say it.
I got it wrong. I also didn't read the question.
That's not very helpful. Okay, real quick, just to make sure to go over it, 'cause I'm sure somebody. Remember, when you're taking a derivative that's not respect to that variable, you need the dx, the dy, the dt, the d whatever. So in this case, we're taking a derivative with respect to lowercase t. So what is the derivative of v with respect to t?
dv dt.
So if you look at the answer choices, only 2 of them have dv dt with lowercase t. So
No, I see.
So C and D are automatically out because they use capital T's when we're talking about the derivative. If we were taking derivative with respect to capital T, that'd be perfectly fine for those answers, but we're doing it specifically with respect to lowercase t for time. What's the derivative of CT on the right? Well, if we remember and read the question, C is a constant, so it just gets to sit out front. And then the derivative of capital T with respect to lowercase t will be dt dt. So that is why the answer is B.
Okay.
Yay.
I would have gotten it wrong anyways.
That's not good. That's an easy question. It's just like pretending those are X's and Y's. So we've done this before where you take it with respect to t and things like that. So it's not anything different than we've done. So just remember that.
Yeah, I got that wrong, but I knew immediately what I did wrong, so.
It's okay. Do I need to do question 9?
Yeah, I need 9.
Okay, hold on, let's start off. Annabelle, what's the area of a rectangle?
Yes. Rectangle base times height.
Okay, good. We got this.
Yeah, I got that.
I mean, at least it's not a triangle, right?
Right.
All right, so rectangle width and height. Very importantly, notice how where it says the width is twice the height. That is very important. Remember when we did all these questions, we were using things to sub in to eliminate one of our variables or to reduce down the number of variables, etc., etc.
Yeah, I hate these.
So we know the area is base times height. It tells us the base is equal to, what's it,
Oh.
2 times the height,
I
basically?
see what I did wrong.
Or height and width, whatever. The
Similar
width
to what I
is
did last time.
twice.
If nobody else needs this question, we can skip it because I realized what I did wrong.
I'm sure somebody else does. It
Okay.
says the height is twice the width, that's the other way around. The width is twice the height. So W equals 2H. So it's very important you get those in the correct order. So let's see. And all of their answers, if you look at all their answers, they have H's in them. So basically we need to get rid of the W. So I'm going to substitute in directly what they gave me. So we know that area is equal to 2H squared. Take your derivative with respect to time. So on the left, it's pretty easy. You get dA dt. What is the derivative on the right of H with respect to time? So the first part should
It's
be
gonna
pretty
be
easy.
dH dt.
But what else? It's not just dH dt. How do we take the derivative of the right-hand side?
So,
Yes, go
Well,
ahead.
you're gonna move the exponent, and it's gonna be like 4h.
And then we get our dH dt.
Yeah, I forgot the dH dt, and I picked A.
Yep, so you got to be careful and remember that when you're taking derivatives with respect to other variables, to not forget to multiply by the dH dt, the dx dt, the dx dy, whatever it is.
I
So you got
remember
to
looking at
remember.
this, and I'm like, huh, that's funny. The inches isn't squared, but I'm gonna put A anyway.
And that was the second thing I was getting ready to mention. Look at your units. If we're looking for the rate of change of the area, that should be inches squared per second. So the only two answer choices would have been B or D. And obviously, since we got the 4H in there, it's got to be D.
I picked B because I was like, one's 2H and one's H. And even though it doesn't really work like that, I just picked. It was really late though.
Yeah, so don't do that.
I should start actually doing these math problems.
That'd be helpful, yes. Okay, we will leave off there because the class is just about over. We'll pick up with number 10 tomorrow. Make sure you're getting your free response done. We should be able to easily finish the multiple choice tomorrow, and we'll see how it goes from there if we do any of the free response. So make sure at least the first free response is done by tomorrow.
Is it for Unit 4 still?
Yes, ma'am.
Yeah.
Okay, cool.